Alright, what's up ladies and gentlemen? For today's lesson with 5-4, we're going to learn how to solve compound inequalities. And before, we've solved single multi-step inequalities algebraically, and we know how to graph the solutions on the number line. So for example, like a single equality would be like x is greater than 5, and we drew down the number line, right? We have a 5 right here, and it'll be like an open dot, and we're going to have all the solutions of x that is greater than 5 in the positive direction. Okay, so now we're going to be doing compound inequalities. Okay, that compound means two, or things that are combined. Okay, and we will solve and graph compound inequalities by identifying where the solution sets of distinct inequalities overlap. Those are and statements, or separate in different directions, also called or statements. Okay, so you're going to be seeing stuff that looks like this, where x can be like also like let's do it right here, like greater than 5, but also like less than 10. Okay, so it's like kind of meshed with these two inequality signs, kind of combined in a compound. All right, so vocabulary is going to be compound inequality, and we're going to learn about how to write inequalities in another way called interval notation. So let's jump right in. Okay, so once again, a compound inequality are two distinct inequalities joined by the words and/or. And there are two ways where you could write these type of inequalities. So the first one is the graph of a compound inequality with the word and contains the overlap of the graphs of two inequalities that form the compound inequality. So let's kind of break this down so you guys can see what I'm talking about here. Okay, so you have x is greater than or equal to 3. So that is going to be a closed dot, as you see right here. And these are all values of x that are my solution in this inequality right here. Okay, so it's all pointing in the positive direction because x is greater than or equal to 3. But there's another value of x right here, right? Remember that this x and this x right here, right, are the same. Okay, same. There has to be the same solutions for both. Okay, so this x on this side is also saying it's less than or equal to 7. So let's close it up, going in towards the less than, so towards the negative direction. And as you can see here, if I draw like a line in between both, they kind of fit right in between. There you go. Okay, right in between from a greater than or equal to 3 and less than or equal to 7. So this is going to actually be my graph for this statement right here. Okay, this is where the values of x work as my solution. Okay, they're kind of bound between those two values. So now let's look at this one. The graph of a compound inequality with the word or, that's the key word right there, contains each graph of the two inequalities that form the compound inequality. So let's look at this right here. Okay, we got this dude. This is like, oh, there you are. Okay, x is less than -2, so that's going to be an open dot going in this direction towards the negative direction. And then you have x is greater than or equal to 1, so that's going to be a closed dot going towards this direction, positive direction. As you can see here, from the points of -2 and 1, there's no overlap between both. So when you actually graph this inequality with an or statement, okay, this is what you have. Okay, when you have two inequality graphs on the same number line, so this guy is going this direction, or the x value can go greater than or equal to 1. So these are the values in which x can be true for both inequalities right there. Okay, so remember, x could either be this one or that one. Okay? So think about the words and or in general. Okay, so when you have Okay, so when I have an apple and an orange, right, I have like a little basket right here. Right? I have an apple and an orange, right, and they're combined, right? They're combined in this one basket when I have an and statement. Okay, they're together. But if I could pick an apple or an orange, right? So I will have to, if I have an apple, right here, apple or an orange, right? I either have to choose either an apple or an orange. Okay, it's either this or that. Okay, I have to pick one or the other and do that. Okay, so and combine or separate. Okay. All right. So now let's look at this. There's another way to also rewrite a compound inequality when you have an and statement. So when I have x is greater than 3 and less than, oh, whoops, I should put this symbol right here. Maybe there should be a that sign. Okay. So when I have x is greater than or equal to 3 and x is less than or equal to 7, I can write it like this. Okay, let me put that equal sign underneath. Okay, because I know that I know that x is greater than, so if x is greater than -3, that's the same thing as like 3 is less than or equal to x, right? All I did was that I combined it with these two, okay, and then I just meshed it together to look like that, okay? So x is squeezed right in between, just like as we see here. When I have x is squeezed in between here, between 3 and 7. Okay, that's another way to write it. So just keep a heads up for that when you're doing that problem, and that's one of your go-formative responses. Okay, 2 ways to write an and statement for compound inequalities. All right, so let's look at some examples, folks. All real numbers that are greater than 2 and less than 6. So this is an and statement. All right. So when I write this, I can write this as so all real numbers that are, so all real numbers is going to be my variable. Okay, that's what it's going to be standing for. All real numbers is any number which be a variable that is greater than -2 and the numbers to be less than 6. So once again, I can write this, okay, kind of flipped around. I could write it as -2 is less than n, and n is less than, okay, sorry, -2 is less than n. Yeah, there. Alright, so then all I do is that I kind of just combine these two values of n, and then I can mesh them together in the middle, like that, so that it is like -2. And that side is less than n, and n is less than 6, and that is my answer. Okay, so when I kind of put it all together on a number line, I know that both of these values, right? This because this is a less than sign. Okay, this is going to be open dot. Okay, this is going to be an open dot, and this is also going to be an open dot. When I graph it all together, this is what I should get for my graph. Okay, n is less, -2 is less than n, and n is less than 6 right there. Okay. Now, what about all real numbers are less than 0 or greater than or equal to 5? Okay, so once again, when I have all real numbers, that is going to represent my variable. So I'm going to choose the letter t this time. Okay. So t is less than 0 or, okay, t is greater than or equal to 5. So once again, if I have an or statement, that means they're going to go in different directions. So, actually, that's already it. And all I have to do is just graph on a number line. Okay? So that is what I get. And remember, if there's no equal sign underneath the inequality, it's going to be an open dot. If there is an equal sign underneath, it's going to be a closed die. Alright, so now I want you to try these problems on your own. Go for it.